Students, today we begin studying Chapter 2, which covers the basics of enterprise VLAN technology. Let's first take a look at some basic concepts of wireless communication. The first is radio waves. That's right. We need to clarify one point about the transmission method of wireless signals. It's whether it's Wi-Fi or AP, 3G, 4G, 5G, etc. Even Bluetooth requires electromagnetic waves for transmission. In other words, what we commonly refer to as radio waves are actually electromagnetic waves. So, how are electromagnetic waves generated? It involves the related theories of Maxwell's equations. Simply put, when the electric field and magnetic fields change, they interact with each other, thereby generating electromagnetic waves. This is also the concept of the relationship between the direction of current and the electromagnetic field that we learn in physics. In this part of the course, we mainly focus on how radio waves are transmitted. Students who have studied mathematics and physics know that radio waves are a type of wave. The propagation characteristics of waves determine the characteristics of wireless communication. Here, we focus on discussing sine waves. The propagation of waves involves several basic concepts. Wavelength refers to the length of one complete cycle of a wave. Is the wavelength fixed? And how is it defined? These are questions that need to be clarified. The second concept is the period, which refers to the time required for a wave to complete one full oscillation. The third concept is frequency. Frequency refers to the number of oscillations of a wave per unit time. Frequency is very important in wireless communication. Different frequency ranges will affect the characteristics of wireless signal. For example, in WLAN technology, we use 2.4 GHz. This frequency band is a free-to-use ISM band. Amplitude refers to the magnitude of the wave's maximum deviation from the 0 point. Amplitude affects the strength of the signal. For example, is a waveform smooth or jittery? This is determined by the amplitude. The basic characteristics of radio waves are the foundation for understanding wireless communication. In practical applications, we can adjust different parameters of radio waves through various technical means. This is to facilitate data transmission via radio waves. As for how exactly this is achieved, we will explain it in detail in the following content. Let's take another look at the frequency of radio waves and the wavelength. First, let's look at the basic parameters of radio waves. The first thing involved is frequency and wavelength. Frequency is divided into high frequency and low frequency. I believe this is very easy for everyone to understand. High frequency refers to how many waves can be transmitted in 1 second. If more waves are transmitted, then it is considered high frequency. For example, if only 2 waves are transmitted in 1 second, then it is the first frequency. The definition of frequency is the number of transmissions or waves that can be completed in a unit cycle, which we call frequency. The second parameter is wavelength. How is wavelength defined? In fact, there is a formula called C equals lambda times phi, where C is the speed of light, which is a constant value, approximately 10 to the power of 8, an order of magnitude. Lambda is the wavelength, F is the frequency. From this formula, we can see that if lambda, which is the wavelength, increases, then the frequency will decrease. If the wavelength decreases, then the frequency will increase. The relationship between wavelength and frequency is inversely proportional. For example, in the millimeter waves mentioned in 5G, if the wavelength reaches the millimeter level, the frequency will correspondingly increase. Frequency, the unit is hertz. When writing frequency, taisong, we often use hertz to express it, such as 2.4 GHz. The G in this context represents 1,000. That is gigahertz. M represents megahertz. We need to pay attention to these measurement units when writing them. Now let's take a look. Frequency and frequency bands. First, high frequencies include gamma rays. Their frequency is extremely high. Lower frequencies are the radio waves we commonly use in daily life. In addition, there are microwaves, infrared, ultraviolet, and so on. Different light waves. The visible light that we can see also has a certain frequency. Why can we see colors? This involves the concept of light refraction. Ultraviolet rays and other various rays or light have different frequencies, which need to be noted. The electromagnetic waves used by WLAN, or what we call radio waves, are located within the radio wave. Frequency band range. For this part, we can read it carefully again. First, our radio waves are divided into several different frequency bands, among which WLAN uses 5 GHz and 2.4 GHz. These two frequency bands are classified as ultra-high frequency, UHF. 2.4 GHz is classified as very high frequency, VHF. Ultra-high frequency, UHF. UF, EF, VF, MF, and LF. Let's just take a moment to look for a moment. 5G is in this location. And very high frequency, VHF, is 2.4 GHz. 5 GHz. These frequency bands refer to ranges of frequencies, not specific frequency values. For example, ultra-high frequency, UHF, and very high frequency, VHF, correspond to different frequency ranges. In radio wave application scenarios, we need to focus on the 2.4 GHz and 5 GHz frequency bands. We can just have a basic understanding of the others. Next, let's take another look at radio waves, some of their special characteristics. Radio phase of the wave. The amplitude mentioned earlier refers to the maximum distance from the 0 point of the coordinate axis, while phase is a time-related concept, indicating the position of the wave at a certain point in time during transmission. In the field of Wi-Fi, we usually divide waves into 360 degrees. Each degree represents a phase point, such as a 90-degree phase, a 180-degree phase, a 270-degree phase, and a 360-degree phase. What impact does phase have on signals? Well, it has a significant impact. Wireless transmission is propagated through the air, relying on energy transfer. If two signals with the same frequency are, if the wireless signals have the same phase at the same time, then when received at the terminal, the signals will superimpose and strengthen. For example, the original amplitude is A. Then, after the two signals are superimposed, the amplitude becomes 2A, which is the effect of phase enhancement. Conversely, if the phases of the two signals differ by 180 degrees, signal weakening will occur. For example, one signal is A and the other signal is negative A. Then the result after superposition is 0. This is how opposite phases can lead to phase weakening. In the actual development of WLAN devices, technical measures should be adopted to avoid signal weakening caused by phase issues. Wavelength, frequency, phase, and amplitude are core concepts in wireless communication. These factors have a significant impact on signal transmission, which can lead to either signal enhancement or signal weakening. Let's take another look at the wireless communication system. Wireless communication refers to the transmission starting from the signal source to the receiving device on the other end. For example, if a sending device wants to transmit text information such as hello, word, but the computer world uses binary language, which is zeros and ones. Therefore, we need to perform sine wave encoding on it. This means converting text information into digital information. In wireless communication, data first undergoes source encoding and channel encoding. Then, modulation is performed. Finally, source encoding converts the original data, such as text, into digital signals, while channel encoding adds redundant information to enhance interference resistance. Modulation is the process of converting the encoded signal into a form suitable for wireless transmission. The channel is the path for signal transmission, similar to lanes on a highway. For example, the 2.4 GHz band is a relatively wide frequency range. And to utilize it efficiently, it is divided into multiple channels, such as channel 1, channel 2, and so on. Each of these is essentially an independent channel to avoid interference. The transmitting device sends it to the receiving device through these processes. In a wireless network, the receiving device receives the signal through the air interface. After receiving the signal, it is first demodulated. It is then converted from an analog form to a digital signal. Finally, it is decoded. The redundant information added during channel coding is removed to restore the original data, and finally, the data is sent to the receiving device. This completes the communication process. Everyone, that's all for today's sharing. If you are interested in Huawei certification or the Huawei certification question bank, feel free to leave a comment below my video, and we can continue the discussion. These are related issues about Huawei WLAN and Huawei certification.